Hey everybody, Mr. Judson here. So we know how to find the derivative of a sine and a cosine, but we also know there's 6 trig functions, right? So today we need to figure out the other 4. So we're going to do the derivative of a tangent, which if I told you guys, alright, you go ahead and try it, probably your first thought would be, I have no idea what to do. Which means, whenever we're doing trig and we don't know what to do, we have to change the sines and cosines. So this would be equal to the derivative of sine of x over cosine of x. And the moment you see that, you realize, oh, fraction, we can use the quotient rule. We learned that yesterday, right? So that means I want low d high. So cosine x, derivative of the high is a cosine of x, less high d low. Derivative of a cosine of x is a negative sine of x. All over low squared will go. And so if I multiply here in the numerator, I get a cosine squared of x, negative times a negative is a positive, sine squared of x over cosine squared of x. Don't think about canceling those, right? Because you can't cancel something that's being added or subtracted to something else. But we do recognize what's in the numerator. That's a Pythagorean identity, right? Sine squared of x plus cosine squared of x, that equals 1. And so that means I've got 1 over cosine squared of x, which is equal to a secant squared of x. So that now means to us that whenever I take the derivative of a tangent of x, I'm not going to go through this process again. I'm just going to remember the answer. This is a secant squared of x. So what if we were going to do a cotangent? Derivative of a cotangent of x. If I just follow that same procedure, let's see, cosine d dx, cotangent is cosine over sine. So when you look at that, you go, oh, well, we're just flipping things over. So yeah, flip this over. Do you just flip that over and it's now a cosine squared? Or is it a cosecant squared? Now maybe we need to work through this. All right, so let's see. Quotient rule again. So low d high, derivative of the high part, less high d low, all over low squared will go. So let's see, I'm going to get a negative sine squared of x minus cosine squared of x all over a sine squared of x. If I factor a negative sign out of there, so I've got negative and then sine squared of x plus cosine squared of x all over sine squared of x. So now that's equal to 1. So what I have is a negative 1 over sine squared of x. And 1 over sine of x is cosecant. So this is going to be a negative cosecant squared of x. So there's another one that we don't have to do again. Anytime I take the derivative of a cotangent of x, from now on, we just know that that is a negative cosecant squared of x. So if you think about it, take the derivative of sine, it's a cosine. Take the derivative of cosine, it's a negative sine. Take the derivative of a tangent, you get secant squared. Take a derivative of cotangent, you get a negative cosecant squared. So I feel like if we can figure out the secant, the derivative of a secant, we can probably assume we know the derivative of a cosecant. So let's try that. Derivative of a secant of x. So I'm still thinking the same way as I did with the tangent. I'm not really sure what to do, so I'm going to change the sines and cosines. So this would equal the derivative of 1 over cosine of x. And then I'm going to do a quotient rule. So this is going to equal low d high less high d low all over low squared will go. So this right here will just equal 0. So what I get is a sine over a cosine squared. Sine x over cosine x squared. And so now I just want to simplify that into something where I don't have a fraction. So what I'm going to do is I'm going to break this down into two different fractions. I'm going to say 1 over the cosine of x times sine x over cosine x. If I multiply these back, you can multiply across the top, multiply across the bottom, and you get the previous line. And so this is now a secant of x times a tangent of x. That is the derivative of a secant. Kind of weird that you take the derivative of something and you get that exact same function plus some extra stuff in there as well. But that's what you get. That's the derivative. So if we think about this, derivative of a cosecant of x, well, it seems like that would be a cosecant of x cotangent x. And let's see, every time I did one function and I did the next one that was similar to it, I ended up with a negative sign in there. And that's going to happen here as well. So we could go back and go through that and see, but that is the correct answer. So let's write down all 6 trig functions. Derivative of a sine of x is going to be a cosine of x. And the derivative of a cosine of x is going to equal a negative sine of x. Derivative of a tangent of x is going to equal a secant squared of x. And so the derivative of a cotangent of x, that's going to equal a negative cosecant squared of x. And if I take the derivative of a secant of x, that equals secant x tangent x. And the derivative of a cosecant of x is going to equal a negative cosecant x cotangent x. So we actually now have 6, 7, 8 formulas. 9 formulas. We've got these 6 trig functions, plus we've got our power rule, plus we've got our product rule, and we've got our quotient rule. That's 9 formulas. Next week we're going to talk about something called a chain rule. So we're going to have another rule. and these rules just keep on building. And you can see why, I told you guys this before, that when we take a test over this chapter, it's kind of hard because there's a lot of rules here we have to remember. And not just that, but we have to know when to apply them and how to use them. So, you know, we need to make sure we put in some good time during this chapter to memorizing and understanding things. I do this every year. I always recommend making note cards. You know, put this on one side of the note card, and then your answer on the back side of the note card. You know, so what's the derivative of this? It's a cosine. And eventually you'll get a pretty decent stack of note cards, and you can just look at them. You know, you can shuffle them, change the order, look at them, what's the derivative? Look in the back, make sure you got it. You know, go to the next note card, check it and see. Every year I tell people to do this. Every year about 2 or 3 people do it, until we get close to the time where we take our formula exam, which is next semester. It's not this semester. Got a long ways to go before we get there. But then all of a sudden everybody scrambles to make note cards. And it's like, why not do it early so that it makes it easy on you? You know, so if you want to start making those now, I think it'd be helpful. It's even, you know, you've heard people say this before, if you can do things forward and backwards, you really understand what's happening. You can look at the answers, kind of play Jeopardy, you know, cosine of x. What did I take the derivative of to get that? And work your way backwards, okay? All right, so let's do a couple problems. All right, so we've got y equals tangent x over x, and we want to find the derivative of that. You guys go ahead and try it. All right, so y prime equals, I've got a fraction, so I have to do the quotient rule. But as I'm doing that, I've got a trig function in here. So I'm thinking low d high, derivative of tangent is secant squared of x, less high d low, tangent x times 1, all over low squared will go. And there's really not much you can do to simplify this. I'd get rid of the 1. I'll just go back and erase that. You know, I could try and convert to sines and cosines and see what happens. But when you've got variables along with trig functions, I would just stop right there and be done. Okay? So that problem wasn't hard. We just had to make sure we knew the quotient rule and we knew what the derivative of a tangent was. Let's try another one. All right, let's try this one. So I've got y equals x plus 1 times the cosine of x. And what I want to do is I want to find the equation of the tangent line when x equals pi over 4. You guys go ahead and try it. So we're looking for a line, which means we need 2 things. We need a point and a slope. So I'm going to find the point first. So I'm going to say that y at pi over 4 is equal to pi over 4 plus 1 times cosine pi over 4. So I know that's a middle tick mark, so that would be root 2 over 2 on the unit circle. I really don't know what you'd call that. If I get a common denominator, it's 4 over 4, so I'd have pi plus 4 over 4 times this. And so that would equal, that's just an ugly number. Boy, that is just ugly. Pi root 2 plus 4 root 2 over 8. And that's my y coordinate. This is my x coordinate. So we know that we've got a point at pi over 4, comma, pi root 2 plus 4 root 2 over 8. I think that's the ugliest point I've ever seen. Now, if we were doing a test and someone was kind of thinking, you know what, I'm just going to change these to decimal numbers. That's okay. Round them off to 3 digits, you know, figure out what it is on the calculator and just write it down, and then find your equation of your line based on that. That'd be okay. I feel like we're always just a little bit better off if we try to give exact answers. I know in college they're real big on that, professors. Give me an exact answer, you know, because they want to be precise. So I'm going to leave it like that, and now I need to find the slope. So y prime, I've got a product rule here. So I'm going to do the derivative of the first, which is 1, times the second part, plus, leave the first part the way it is, and take the derivative of the second part, which will be a negative sine of x. And now I just need to evaluate that at pi over 4. So if I plug a pi over 4 in here, I get, again, middle tick mark, so root 2 over 2, plus pi over 4, plus 1, times a negative root 2 over 2. Boy, if that xy coordinate wasn't ugly enough, our slope is going to be even uglier. This is, well, actually, no. It does simplify a little bit, but it's still kind of messy. So let's see, I'm going to do this. Oh no, this actually might be kind of nice. Root 2 over 2. And I'm going to distribute this to each of these. So I'm going to get a negative pi root 2 over 8. And when I multiply here, I'm going to get a negative root 2 over 2, which means those add up to 0. And so there's my slope, a negative pi root 2 over 8. And we're trying to find the equation of the tangent line. So I'm going to say y minus the y value, so minus the fraction pi root 2 plus 4 root 2 over 8 equals the slope, which is a negative pi root 2 over 8 times x minus the x value. Remember how I told you that on the AP test you don't have to simplify? That would be a good place to stop right there. However, what if it's a multiple choice question? We got to keep on pushing forward on this. So I'm going to say y minus this fraction, pi root 2 plus 4 root 2 over 8. I'm going to distribute this. So I'm going to get a negative pi root 2 over 8 times x. Negative times a negative would be positive. Oh boy, now I've got pi squared root 2 over 32. And then I just need to move this fraction to the other side and add it so that I get y by itself. So y equals a negative pi root 2 over 8 times x plus this fraction, pi squared root 2 over 32. And if I move this to the other side, it becomes positive, so plus pi root 2 plus 4 root 2 over 8. And I'm just kind of looking at this and trying to think to myself, if I did get a common denominator, you know, multiply top and bottom by 4, is that really going to do anything for me? No, it's not. I'm going to stop right here
And, just so we get this, if we think y equals mx plus b, okay, there's the m value, and whatever this is, that's your y-intercept, the b value. Okay, but I'm just going to stop there. I have an exact answer. What does this whole thing equal? I really don't care right now. I'm just going to stop there. Okay, let's try one more. All right, let's go ahead and see if we can find the derivative of this equation. So this looks like a product rule, since we're multiplying two things. So I'm going to think to myself, y prime is equal to derivative of the first. So derivative of secant is secant x tangent x. So derivative of the first times the second, plus leave the first piece the way it was, and take the derivative of the second. Derivative of a sine is a cosine. And then we got to see if we can simplify that. Okay. Now I know you guys are going to want to ask me this question all the time. Do we have to simplify trig expressions? To me that's kind of like, do we have to simplify fractions? Yeah, we should try and simplify that. So let's see, if I simplify this, I'm going to get, and I always like to just think, change the sines and cosines, see what happens. So if I make this 1 over the cosine of x, I know that the tangent is sine over cosine, and then a sine of x there, plus, this is 1 over cosine of x times a cosine of x. So what I get is sine squared over cosine squared, plus, this is going to be cosine x over cosine x, which is equal to 1. So right now, and I know we may not be as good at this as we should be, because last year we were trying to do everything remote when we talked about trig, but the moment you see an exponent of 2, especially when there's a 1 involved, it should make us think of those Pythagorean identities. Remember those three? There's sine squared plus cosine squared equals 1. We mentioned that just a second ago. And then there were two more. One is tangent squared of x plus 1 equals a secant squared of x. The other one is cotangent squared of x plus 1 equals a cosecant squared of x. Again, that chart in the back of the book, the very last page in our electronic book, it's got all the trig stuff we learned last year. I would get to that page and try to print it out, okay? Or use your snipping tool and get a picture of that, put it into a Word document and print it out. Because we're going to want to be able to refer back to that. This is a tangent squared. And last year we said that was equal to a secant squared of x. You guys might remember this. I did this chicken scratch thing. I did my chicken scratch where I've got sine squared plus cosine squared equals 1. And then to get a tangent, I'm dividing by a cosine squared. So I look at that and go tangent squared plus 1, that equals a secant squared. So I can always figure out the other ones if I forgot them. So there it is. There's our derivative. Now I wish you guys were here because at this point I would give somebody a chance to shine. I'd probably ask the question, did anybody do this a little different? And usually there's somebody. There's usually somebody who would look at this and go, well, isn't that equal to 1 over the cosine of x times the sine of x? Which when I multiply that I get sine x over cosine x, which is really a tangent x. And isn't the derivative of a tangent of x the secant squared? Could have gotten there a lot quicker, right? Yeah, sometimes we get our mindset so that we're looking down a tunnel. And we got to make sure we're looking this way. You know, there's other things that are possibilities. We got to remember those. So yeah, we could have made this one a lot easier. Yeah. All right, so that's what we have for today. We're adding the 4 new trig functions. Of course, when they start asking us to find derivatives, they're going to work in the other things that we talked about as well. Your product rule and your quotient rule. So we've got a lot of stuff all of a sudden getting mixed together that we got to make sure we understand that. All right, let me get you guys an assignment. All right, so we're finishing up week 8. This will be the last piece to it. Page 129, 45 to 56, and 60, and also 67. So we already talked about this in our class today, but I just want to make sure that everybody's aware of this. Monday, I will be on the other side of the mountains. I will be working from there. I'll take my laptop and my document camera and stuff along with me. But I just wanted to say, just in case there's some kind of glitch, if I can't get a Teams meeting started, I don't know about the Wi-Fi where I'm at, I will let you guys know. I'll send an email to you and let you know what's going on. It also may be that I have to do something a few minutes later than normal, but still during first period. So just keep your eyes open for emails on Monday so that we all know what's going on. All right? All right, that's all we have. You guys take care. Have a good weekend. Stay safe. Go Hawks.